Hello everyone, welcome you all to Plastics News Hour. This is a Technobiz weekly online program for the global plastics industry. In this news hour, we will have a kind of technical talks, panel discussions, leadership conversations. I welcome you all for this Plastic News Hour. Today, our session is focusing on the net zero 10 top tips for plastics processor by Dr. Robin Kent, Tangram Technology based in the UK. So he will be giving a talk on this net zero issues related to the plastic industry. Before I invite him to give a presentation, let me brief you to all about the Technobiz. This program, Plastics News Hour, is managed by Technobiz. Technobiz is a company based in Thailand, established in 2005, and it is recognized as the International Resource Center for Polymer Processing Industries and also process manufacturing technologies. We'll just give you an overview about the services we offer. Of course, a lot on professional education. We offer online master classes, workshops, publications, and also library. And we have various business services on the exhibitions, conferences, virtual events, road shows, networking events, technical and business consulting, marketing and branding. And our emphasis is a lot on polymer industry. When we talk about polymer industry, we talk about rubber, plastics, polyurethane, adhesives. And we also on the non-polymer side, energy and environment, membranes and filtration, recycling, recovery, and also nanotechnology and smart manufacturing. You can always find more information about Technobiz at technobiz.org. Just give you what kind of news hour we host. We have currently 5 different news hours. Rubber industry news hour is a weekly. Latex industry news hour is fortnightly, once in 2 weeks. PU news hour is also fortnightly, focused on the polyurethane industry. That is, and we have advanced technology news hour, which is about to started, aimed to be weekly, and plastics news hour is a weekly. So through these news hour programs, we try to keep update in the industry developments and the changes happening in the industry. Let me quickly introduce to you all about what we do for plastic industry. So there's a news hour. We can see various experts from across the world. They're giving a specific subject as a presentation in this news hour program. I do encourage all of you to subscribe to this plastics news hour so that you can join on regular basis as per your convenience. These are also available in record session after the session is over, and you can check our Technobiz channel on YouTube. It's next day of the live session, we post the record session. So if you are very interested to make a presentation in the news hour, we welcome all the experts are welcome. And so here is some more the experts. Some of them are technology suppliers, some of them are consultants, experts in respect to the plastics processing. And we have trade exhibitions and focus regional exhibition for the plastics industry. You can check more details at expo.technobiz.org. We are going to host a plastic extrusion expo in Bangkok during 29 to 30 March, focus on the extrusion compounding. We have a roto molding trade expo. And this is we are hosting 2 different locations in this year, one in Bangkok, another one in Sharjah near Dubai in November. So please check our website expo.technobiz.org. We have other event called Polymer Laboratory Expo, focus on the polymer laboratories and testing instruments. And other one is recycling and recovery technologies and practices. So these are the exhibitions we organize for the radial plastic industry. We offer various the booth options. Okay, and whether you have budget is less, where budget booths are there, premium booths are there, and standard Celsius booths are there. Training programs. One of our specialization technologies is training programs. We work with a lot of experts from across the world offering various specialized training programs. Here are some of the training programs available online. You can view them on demand as per your interest. Some of them on the injection molding, some on film extrusion, general extrusion as well, and also the resin side and polymerization. We do keep on adding the more topics in the near future, so please do check our website technobiz.org for the available training programs. And we have a rotation molding as well. Okay. Another thing we do is a Plastics Connect, is a digital marketing service for the global plastics industry. We promote companies and technologies. We offer memberships, platinum, gold, and silver member. And so through our network, we promote the technologies and the products. And we also host the Plastic Tech Talks. It is basically customized online or in-person tech talks for the global plastics industry. They're basically sponsored presentations. And we have a roto molding network, which is basically the network of rotation molding professional businesses. And for this network, we are very specialized in organizing various activities with rotation molding, exhibition, training, management, leadership sessions. We have a newsletter, and we also work with all the rotation molding organizations. So I welcome you all to be part of TechnoBase, and if you think we can assist you anyway, feel free to reach out to me, and this is my contact information. My name is Peram Prasadarao, and you can reach me by email or by WhatsApp. Cheers. Welcome you all to the Plastics News Hour, and today's topic is on the Net Zero 10 Top Tips for Plastics Processor by Dr. Robin Kent, Tengram Technology based in UK. Let me quickly introduce about Dr. Kent. He has been involved with the plastics processing since 1972, pretty long time ago, in a variety of sectors, ranging from extrusion to injection molding. He has many years of experience in product design, have worked as a technical director for several of the major plastics processing and window systems companies in UK and Europe. Currently, is an independent consultant. He has carried out energy surveys and assessments on over 500 plus companies throughout the world. He has publications over 500 technical and management papers on plastics, and he has written 10 books on plastics processing. He regularly lectures on energy management, plastics processing, and materials technology throughout the world. So that's information on the Dr. Robin Kent. You can see he's well experienced, veteran in this area. So let's welcome Dr. Robin Kent to give a talk on the Net Zero 10 Top Tips for Plastics Processor.
Oh, yes. Good afternoon. I hope everybody can see my screen now. We're going to cover 10 top tips for net zero. Net zero is a new topic. 2 or 3 years ago, nobody had ever heard about net zero. But right now, net zero is one of the most pressing topics that we've got in the plastics industry, and in fact for the whole world. So let's look at what net zero is. And this is from a guy by the name of Michael Kelly. He says, we don't know what we must do to achieve a net zero economy, whether it will have any meaningful effect on global temperatures, and how much it will cost to get there. But we've set a date of 2050 to get there. Now, Michael Kelly was an inaugural Prince Philip Professor of Technology at the University of Cambridge. He was a chief scientific advisor to the UK government between 2006 and 2006 and 2009. He knows a lot of stuff, and he actually says we don't know enough about net zero. In terms of where we're going next, Fatih Birol, who was the executive director of the IEA, that's the International Energy Agency, he says basically about half the reductions to get to net zero emissions by 2050 will need to come from technologies that are not yet ready for market today. So this is a real challenge. We've got something where we don't quite know about the technologies that we're going to use. We don't quite know how much they're going to cost, and yet everybody's talking about it. So let's talk about why net zero, because net zero, there's this words that people don't quite understand what we're trying to do in net zero. So the diagram you see on your screen shows two different carbon areas, carbon cycles. One is the short or biogenic carbon cycle, which is sort of basically days to hundreds of years. And basically animals and plants take in carbon dioxide and use it to respire or photosynthesize, and it gets moved around this short carbon cycle. Then you have this long carbon cycle where material is fossilized, it goes into calcium carbonate, and it's the long cycle where we've got, this is over 1 million years. This is basically where we end up with oil and gas being subducted, and we end up, it's underneath the earth, and then we start to burn it. So there is a lot of talk about the greenhouse effect, and without the greenhouse effect, the Earth will be about 30 degrees centigrade colder. That means even on the hottest days, it would be a new ice age. And over the last 3 million years, the ratio of carbon dioxide in the atmosphere has been somewhere in the region of about 180 to 350 parts per million by volume. And just before the Industrial Revolution, it was about 280 parts per million by volume. But the use of fossil fuels in the last century or so has led to this number rising to about 354 parts per million by volume in 1990, and it's predicted measured at about 420 by 2021. So this rise in carbon dioxide in the atmosphere, it is actually minuscule in the sense of carbon dioxide numbers, 350 parts per million by volume. But it's incredibly important, and the average global temperature has increased by about 1 degree C so far, and it's forecast to rise even more, 1 to 2 degrees C by 2100. And that will have significant effects on the Earth and on humanity. I must say, it doesn't matter if you agree that man-made climate changing is, man-made effects are causing climate change. The landscape is changing and society is changing. This is a movement. What we need to understand, though, is that it is net zero and not gross zero. It's decarbonisation, but not de-plastics. If you have a look at this chart, you'll see the gross emissions is this dotted line. So we'll end up with some net gross emissions, and somewhere around 2035, we'll get some capture of carbon so that the capture of carbon is taken out of the atmosphere. That will be a negative, and the hard to abate emissions will remain, but overall what we want is that the net emissions come to zero. That's why it's called net zero. Plastics are essential enablers in getting to net zero, and we'll talk about that in later bits of this presentation. So it's not de-plastics, it's decarbonisation. So how are we going to get to this bit? This is the IEA projections. How are we going to get to this bit about reducing emissions? And what are we going to do with this capture of emissions, which is predicted to start in 2035? Well, we're going to reduce emissions through a combination of reduction in fossil fuel use in transport, heating and processes. We're going to end up with electrification of all the systems. We're going to have these energy efficiency. That's essentially what we'd call demand side decarbonisation. So we're going to reduce the fossil fuel, electrify and energy efficiency. And the second bit, which is that emissions capture, is carbon capture, usage and storage. So this is actually not something that companies have a huge effect on, although they can do their little bit for it. Something like emissions capture is really huge engineering projects. We've got to look at how we can take 350 parts per million of carbon dioxide out of the atmosphere. So how are we going to get this emissions reduction? Because that's what we're going to focus on in this presentation. Emissions capture is far too complex for us to think about in this presentation. So let's look at where do we start? How do we start? So supply side, that's the generation of electricity. I'll go back a second. We've got this supply side decarbonisation. That's how do we decarbonise electricity supply? Well, supply side, that's about 21% of carbon dioxide emissions. That essentially says that in the UK and a lot of other countries, China, Australia, they're burning gas, they're burning coal, they're burning oil to provide electricity, and we're rapidly, at least in Europe and lots of other areas in the world, replacing carbon dioxide forming stuff that's like fossil fuels. We're replacing that with renewables, and that's actually something that's grown apace in the last 10 to 20 years, and that's happening very quickly. On the demand side, that's 79%. That's all of these bits here. We're going to do this through fuel substitution, and we're going to do it through electrification. This means we're going to have to look at how do we electrify transport, how do we electrify residential use, agriculture, and all of that. It's actually a wholesale transition of the economy, of every economy, and of our way of life. Now, I should point out that these numbers here are for the UK, excuse me, they're the 2019 UK greenhouse gas emissions. They probably won't be very different from many other industrialized countries. And if you're in Asia, maybe your energy supply is generating more because you maybe haven't got the number of renewables that have been installed in the UK. The plastics industry is quite lucky in the sense that we've already electrified, but in a sense, the survival of our industry is almost irrelevant compared to the changes that will occur outside our industry. And the costs and mechanisms of this transition of the economy and of our way of life are still uncertain. So let's try and get a look at what we do in terms of emissions. We're going to focus a bit more in terms of the plastics industry and companies rather than the overview, which is like the country and the world factors. We're going to look at companies. So what are the companies going to do? Well, we have this thing called the carbon footprint, and for a plastics company, the emissions are divided into these things called scopes 1, 2, and 3. And essentially this division is by the degree of control a site has over the emissions. And this can be termed the carbon footprint. So scope 1 are the direct emissions where the site controls the asset. That's where you burn the gas or the oil or the bottled liquid gas, that sort of thing, where it happens at the site or in the direct control of the site. We have scope 2, which are the indirect emissions from imported utilities. That's emissions from the purchase of electricity. So you're using electricity in your plastics factory, but equally somewhere along the line, somewhere hundreds of miles away, there's a site burning gas, maybe burning coal, however it's generating, but there are some emissions at the generation station. And then there's scope 3, which is the indirect emissions where you don't control the asset. I guess a good example of this would be if you fly on an aeroplane on a business trip, you don't own the plane, you don't control the asset. So what you do in scope 3 is you take a little bit of the emissions from the asset use. So that can be things like cars, planes, trains, taxis, that sort of stuff. And it's very difficult to quantify those, although there are tables to do it. And I do this as a matter of course. That's part of my day-to-day business is calculating carbon footprints. So how big is it going to be? Because your plastics processors and you're interested in how big it's going to be. Well, at least in the UK, as a quick estimate, or actually most of the industrialized nation, as a quick estimate, the emissions in carbon dioxide will probably be about 1.5 to 2.5 tons of carbon dioxide per ton of polymer processed. That means if you process 1,000 tons of plastic in a year, doesn't really matter whether you use extrusion, injection molding. Certainly for roto-molding, it'll be slightly different, but if you process 1,000 tons of polymer, your emissions in terms of CO2 are going to be somewhere between 1,500 and 2,500 tons of CO2 per year. And as a rough comparison, the average household in the Western world uses about 10 tons of CO2 per year. So it's going to be quite large. If you're processing 10,000 tons of plastic a year, that means your emissions upper limit is going to be, say, 25,000 tons of CO2 per year. It's quite a significant amount. So what are we going to do? We're going to look at carbon footprinting. And carbon footprinting can be in terms of the whole of the product. And unfortunately or fortunately for plastics processors, we normally manufacture a single component. So you can have, if you're looking at the site carbon footprint, it would be this little bit here. Those are the manufacturing element of the plastic component. But if you look at the cradle to grave for the whole product, then the plastic component is only part of it, and it must be matched with some metals, some other bits. If you consider a car, there's lots of metal manufacturing, there's lots of circuit board manufacturing, there's rubber manufacturing, and the plastic components that go into it are but one bit of the total product carbon footprint. And it's interesting that we're trying to look at the whole emissions cycle, that's cradle to grave, and we need to focus on what are we doing in terms of products that save energy. So Scope 3 emissions are really important. They cover the upstream and downstream emissions. But in actual fact, it doesn't matter how you calculate the carbon footprint. There's no current method of dealing with CO2 savings as a result of the product's use. We can very accurately calculate the carbon emissions during a product life, but the saved carbon is emitted. To give you an example, one of the big challenges, at least in the temperate climates, is heating of houses, which is primarily done today by gas. One of the biggest things we can do to reduce heating demands is to insulate our houses. This, in a lot of cases, requires plastic insulation, polystyrene insulation, that sort of stuff. And we can accurately calculate the carbon emissions associated with producing the insulation for the house, but there is no current methodology of calculating or quantifying how much we save as a result of the use of plastics products. So let's have a look at some low carbon products or some carbon products, and we're going to just quickly scan through a few products and look at what their carbon footprints might be. Let's have a look at some food packaging. Food packaging, the average life of food packaging is less than 2 years. And we talk about the product life cycle. That's from when the product is put into the packaging to when the consumer has finished with the packaging. And 88% of the carbon footprint is in the raw materials and manufacturing phase. 52% is in the raw materials. So there is a small end of life contribution there, because that's when we capture it in what's known as the municipal solid waste stream. If it's being recycled, there's actually an impact in terms of the recycling emissions, and this has an impact on the carbon footprint. And if we look at, say, what happens in the UK, food waste in the UK is valued at about £19 billion a year and has about 25 million tonnes of carbon dioxide associated with it. But the total CO2 emissions of the UK plastics industry are somewhat less than 4 million tonnes. Packaging is about 50% of that. So the packaging emissions are about 2 million tonnes. So if we can actually preserve the life of food and reduce the 25 million tonnes of food waste or carbon dioxide associated with food waste, we can actually end up with a plastics industry which is net carbon positive. Let's have a look at something like PVC window frames. They have an average life of 25 to 50 years, and the largest impact of the carbon footprint is in the use phase. This is because windows are appliances. You put them into houses and heat goes in or out of these windows, and the loss or gain of heat is actually part of the carbon footprint in total. So other long life products, plastic pipes, may show different carbon footprint terms because they don't necessarily use energy in the use phase. So I think we've got to say that this is a very difficult subject to deal with. I've tried to skim over some of these things, but to say at this stage, net zero is a real challenge for the plastics industry. And what I want to do now is go into the big things, the 10 top tips that we can do. And there they are. It's become carbon neutral, reduce energy use, use renewable energy sources, reduce absolute materials use, reduce materials types, recycle materials, bio-based, heating use, transport, and minimize waste. We're lucky, as I said, that most technologies, with the exception of rotomolding, are electrified, but other industries are going to make huge process changes. So let's step through these 10 top tips and give you some advice on the sort of things you can do to reduce your carbon footprint and move on this journey towards achieving net zero. Let's talk about becoming carbon neutral. There is a standard for carbon neutrality. It's the British Standards Institution PAS 2060 specification for the demonstration of carbon neutrality. Carbon neutrality to PAS 2060 is not, and I must repeat that, it's in capitals on the slide, it's not the same as net zero, but it's a pathway to net zero. Here's a picture of an Australian wine. Certified to PAS 2060, and it's got this lovely little 100% carbon neutral. I think you'll applaud my dedication to the topic of carbon neutral or net zero by the fact that I only drink 100% carbon neutral wine. So how do we get carbon neutrality? It's a 4-step process. We have to measure the carbon footprint, which is the sort of techniques we discussed earlier. We then have a plan to reduce our carbon footprint. We then offset our residuals and we document and assess conformity. Measuring the carbon footprint, discussed, reduce carbon footprint, we'll cover that in several of the next steps we're going to cover, and offset the residuals. This is something which most people get a little bit confused about. What is carbon offsetting? How useful is it? How does it work? Well, offsetting used to be a bit of Wild West. There are 2 different types of offsetting. There's emission reduction and there's emission capture. Emission capture is the carbon capture, use and storage, which really isn't being done now to any great extent. And in fact, the IEA says it's not going to have a significant impact until 2035. So, but we can do emissions reductions. We can do avoided emissions. And that's where we can have projects to avoid emissions, and we can have reduction with storage, short or long term. Most of the offsets that are available today are in this area, short-term storage or avoided emissions, and its offsetting is a step along the road. Basically, it's how do we have a market whereby I give you money to avoid emissions, and then I calculate your avoided emissions as part of mine. So it's a marketplace. It's trying to bring economics to carbon trading. So that's how we get to carbon neutral. Carbon neutrality, it's quite a simple program. It's measure, reduce, offset, and report. It's a step along the way, and I would strongly recommend it for most companies to get to carbon neutrality, because it starts to provide all of the necessary pointers as to how we eventually get to net zero. So the second step is, how do we reduce energy use? Well, for most plastics processors, and I must confess, I've only done energy surveys for about 500 plastics processing companies around the world. 30% reductions in energy use are possible. That can come from management actions, about 10%, maintenance actions, about 10%, and CapEx, about 10% as well. The savings that we can generate are in all areas of the site, but most companies have simply focused on lighting. That's that 5% up there. And they wonder why their energy efficiency program has not delivered the required or the potential gains. It's possible for you as plastics processors to reduce your energy use by 30%, and this would reduce your emissions by about 27%, which is quite a hefty lump of the getting to net zero program. What's the next bit is we can use renewables. It's a very complex subject. There are grid renewables whereby we have things called power purchase agreements, where renewable energy is generated by somebody the owner of a solar farm or a wind farm, and they can sell that green energy to companies. That is where we have the best bit. There are things called renewable energy certificates. These are where we decouple the environmental benefits from the electrons. I always sort of think the actual electrons you use may not be generated renewably because the power generation system doesn't understand it, but you can buy renewables from the grid. The alternative is to actually think about, we're going to do self-generation. We're going to go for solar PV on the roof of our factories, or we're going to try and mount a wind turbine in the factory. Well, the reality is that in most of the Western world, in most of the industrialized countries, there simply isn't the space or land, space in terms of roof space or land available. If I've got some typical data, this is solar output by day, southern UK, south facing. You can see lots of generation in the summer, which is this bit here, and not much generation in the winter. A typical UK site carpeting the top of their factory with solar panels could expect to generate about 16% of their yearly energy needs. That'd pay for the lights, the offices, but wouldn't actually do much towards the actual injection molding or machines or the extruders. And in the UK, at least, most sites aren't suitable for on-site wind turbines. So renewable on-site generally can be useful. 16% is a worthy gain, but in terms of paybacks, it's very long-term. Most of the payback for investment in solar PV or wind turbines, you can expect a 7 to 9 year payback time. It's quite long if you're used to try and justify your capex as inside 3 years. So what can we do? We can reduce the use of materials. Every material we bring into every piece of material we bring into our factory, our plastics and all of that has an associated, what we call an embodied carbon, and we want to reduce the use of materials. Now, the way to do this is form a materials team and set the target that you want to reduce absolute materials use by 8% over a year. This can be done by two methods. There's one which is reducing the raw materials content. That's typically the light weighting. And if you consider a yogurt pot, the weight of a yogurt pot has reduced by about 70% over the last 10 years because they've been lightweighting the product. So we can look at how we're reducing the content of the content of the product That's 4% we should be thinking about saving. And reduce materials use in production. That's a housekeeping exercise by at least 4%. But we want to be talking about an overall 8% use and emission savings on raw materials. Most of you are going, how can I do that? But it's not just the plastics. It's also the water we use. It's the packaging. That's packaging that comes into us and packaging we send out to our suppliers. It's about the solvents we use. It's about the oils, about the hydraulic fluids, the metals, the filters, cleaning fluids, clothes, waste, and office paper and materials. We need to start thinking about how do we get rid of these waste materials, and we'll talk about waste minimization as a separate topic later on, but we want to think about reducing the raw materials that come into our factories by at least 8% over a year. So we want to reduce our materials use. We also want to reduce our materials types. One of the ways we're going to get to net zero is we're going to use recycled materials, but we really start to need to use materials that can be recycled. And we need to start saying we want to choose materials to maximize our mechanical recycling. Well, there are really only 4 families of products that are mechanically recycled. That's the polyolefins, all the polyethylenes and the polypropylenes, the polyesters, the PET bottles, and those are the main ones that are recycled, at least in the UK, mainly in Europe and the USA. The styrenics, the polystyrenes, and the vinyls, they're recycled slightly. Vinyls are mainly recycled in terms of an industry program, and styrenics, it depends where you are, how they're recycled. All the rest of the materials, the polyamides, the polymethyl methacrylates, the POMs, the fluoropolymers, none of those are recycled by mechanical methodologies. So we need to start to focus on what materials we're using and stick to things like the polyolefins and the polyesters, so we can actually start to think about getting a recycling infrastructure so that none of our materials which go into our factories, none of them end up in landfill, and particularly none of them end up in the oceans. So we need to choose materials to maximize mechanical recycling. If we can't choose materials to maximize mechanical recycling, then we should at least choose compatible materials and use them in very small elements so that we can, in terms of recycling, the compatible materials can be reground in bulk. We need to remove other materials. We need to start thinking about how do we get screws and metal fixings out of our plastics products because they interfere with the recycling process. And we need to identify the materials to make it easy for mechanical recyclers to sort and process. And in a sense, we need to make sure we've also got that recycling infrastructure, because if it's not sorted, if it's not collected, it's not sorted. If it's not sorted, it's not recycled. And if it's not recycled, it's probably going to end up in landfill. We need to actually reduce the number of materials types. We also need to use recycled materials. Recycled materials have a lower embodied carbon content, and this is a sort of schematic of the methods of recycling. Please note that internal reuse, that's where we take the sprues and runners and regrind them and feed them back into the process. That is not classed as recycling. There's an ISO standard on this. It's internal reuse. It is not recycling. Where we get the only time we call it recycling is when it's been manufactured, used, and at the end of life. If it stays as a polymer, it's mechanical recycling. And then we've got what we call chemical recycling, and there's really 3 separate methods, one of which gives you a raw material, one of which gives you a monomer, which has got to be polymerized again, and the other which goes back to a recycling feedstock. It's basically the same as oil. So using recycled material, you can reduce the carbon footprint or the embodied carbon of the material by about 80%. So we need to start thinking about how we're going to use mechanically recycled material. This is a long process. We need to start setting up these supply chains and trialing recycled materials. The actual biggest limiting growth to mechanical recycling is the mechanical recycling infrastructure, because it simply isn't there in the volumes we need to generate enough mechanically recycled material. But it's coming, and we need to start thinking about our products. How do we get recycled materials into our products? Can we use multi-layers? Can we use 100% mechanically recycled material for non-visible parts? We need to start thinking, how do we get these recycled materials into our factories? We can start thinking about using bio-based materials. Now, there's a lot of confusion about bio-based. And there's this phrase which they use, which is called bioplastics. And that's very confusing. There's two elements to bioplastics. One is bio-based raw materials, where we use a biomass for the basic material, and the other end of the bioplastics is the biodegradables. Now, bio-based plastics describes where the materials come from. It's about raw materials. It's got a lower carbon footprint. They can be carbon neutral. And bio-based materials, it's entirely possible to produce what we call drop-in materials. You can have a bio-based polyethylene, which is virtually indistinguishable from a fossil fuel-based polyethylene. They can be partly or fully bio-based. That means you can have some polyethylene generated from biomass and some bit of the polyethylene generated from fossil fuels. And they may or may not be biodegradable. A drop-in polyethylene is no more biodegradable than a fossil fuel-based polyethylene. They'll be more expensive because the raw material is more expensive. That's the biomass. And because in essence, the chemical engineers haven't had 100 years to perfect getting all the processes right. Bio-based materials may or may not run on existing tooling if you're going to use them. Excuse me. We need to start as an industry looking at bio-based plastics, and we need to start figuring out how we can get these into our factories. And again, I'm going to say this is not about biodegradables. Net zero is not about biodegradables. Biodegradables is about how we deal with materials at the end of life. It's not anything virtually to do with net zero. It's not even anything to do with littering, because we are not sure that using biodegradable plastics actually contributes anything to the debate about littering and ocean plastics or anything like that. Let's stick to the topic though, and what are we going to do? Use bio-based materials, start to get some experience. They're going to become more important. We can reduce heating use. Heating use for most plastics processing sites is quite minimal. Heating use for offices is generally gas, at least in the UK and most of the industrialized nations. We need to start thinking about how do we set the offices at the correct levels, which I've given some examples there. How do we capture waste heat from processors, compressors and chillers? And what do we think into how can we maybe consider using heat pumps? For Asian countries, for most of the Southeast Asia, you won't be terribly worried about heating, but for Western countries, actually heating will be sort of 5% of the carbon footprint, because we use heating for office spaces and frost protection in warehouses. So how are we going to do? The next bit is how are we going to reduce our transport impacts? Most of the transport, because bear in mind, we're looking at the whole product life cycle. Transport is part of the carbon impact of both the product and the company. And for most of the plastics processing industry, product transport will be by contract hauliers. Not many plastics processors want to run a fleet of transport trucks, and the product transport will be, depending on where you send it and how far your customers are from your factory, can be about 10% of the total carbon footprint. The big hitter in terms of carbon footprint on a global scale is private vehicles. Our industry is probably light vehicles and commercial freight vehicles. Not a lot of ships used for transporting plastics products. Air transport can be used, but I've got to say the graph there says, or the chart there says, don't use air freight. Air freight is probably about 10 times as carbon intensive as a heavy goods vehicle, that's a truck, and about twice as carbon intensive as using a small van. So don't use air freight. Whatever you do, it's very expensive and it is very carbon intensive. What can we do about it? We need to start thinking about setting up what we call a sustainable distribution program with the haulier, based on two stages: minimize the demand and then optimize the supply. We need to start thinking about reducing the distance traveled, reducing the amount transported, improving our load factor, improving our space utilization, and reducing our empty running. In most cases with plastics processors, we end up with the vehicle is full with product before it's anywhere near the load carrying capacity. So we need to start thinking about how do we stack things better? How do we get more product into our vehicles so we don't spend as much, or we don't have as much carbon emissions from our transport impacts. Electric vehicles for HGVs, that zero emissions at the tailpipe, are a long way away. EVs for domestic vehicles, for private cars, certainly doable. We're seeing a growth, although I still own a petrol-based vehicle because I suffer from severe range anxiety. That means if I've got to drive to a client of mine and they're 300 miles away, if I drove an EV, it would probably involve a 2-day journey. For HGVs, it's possible to buy things called high blend renewable fuels, these HBRFs, and that's alternatively known as biodiesel. Most diesel bought at the pumps in the UK at the moment includes an element of biodiesel. Got to start thinking about how to reduce our transport impact. The next bit is we've got to minimize waste, and this is where we think about waste. And most of you, if I ask you about waste, you think about, oh, it's the skip charges and potentially some effluent charges. And the visible cost of waste is not the reality. As with an iceberg, most of the costs are hidden and invisible. And here are some of the invisible costs: business insurance, regulatory compliance costs, packaging notes, staff time, recycling costs, lost labor. Most of the true cost of waste is hidden. And when companies want to minimize waste, they tackle the visible bits, which is skip charges and effluent charges, but they're more than often not the major costs, they're just more visible. So where are we talking about waste? Well, when we're talking about waste, we have these code words. And I've been in factories where they put up signs which say stop waste. And I actually get quite offended by that, because most of our people actually want to stop waste. The real challenge is to find waste. And if you have a look at some of these code words, purgings, quality samples, re-lens, strippings, regrind, rejects, we have these code words, and we, in the accounts, we will put them in as runners or samples or scrap, or a startup allowance, and we will put these in the accounts, but the reality is these are wastes. And once you stop thinking about code words and you start thinking about these are real wastes, these are real money, we can start to do something about it. Every waste has a source, a destination, and a justification. That's we justify it even if it's wrong. The code words are there's loads of them, and you've probably got other code words for wastes in your company. They make the waste acceptable, where we go, yeah, it's stock loss. That means we don't have to do anything about it. The reality is stock loss is just a code word for waste, and we do need to do something about it. We need to start waste minimization, eliminate, reduce, reuse, recycle, recover, and disposal. You need to start thinking about waste min. And we in the UK, I used to run a waste min workshops, and we found it was quite easy to reduce waste by 20% within a year, quite easily, just by focusing on the invisible waste, which people justified with their code words. So what are we going to do next? We're going to start, you need to start planning today. I've given you 10 top tips. You need to quantify what you need to do, and you need to start to plan for net zero. These are things that are going to come. You're going to need to be prepared, and you need to start thinking about them today. My last bit is don't make a pledge without a plan. Don't sign up and have a meaningless page on your company website which says we're committed to net zero. Get your plan first and then commit to net zero. Thank you, ladies and gentlemen. That's it. We'll go over to questions now.
Thank you very much, Dr. Robin Kent. Excellent presentation, eye-opening statements. Thank you very much. Let's have a short discussion on the questions received from the audience. Let's take a few minutes here. Guys, if you have any questions, you can post questions in the question box, and I will address them in this session now.
Okay, first question. If you were just starting out, then how long would it take to become carbon neutral? The process could be fairly easily achieved in 3 to 4 weeks, a month or two, depending on how long it takes you to get the data together for your carbon footprint. But it's actually a very simple process. I would say if you wanted to be carbon neutral, allow 1 to 2 months, fairly easily. Okay, thank you. Can I please comment on the energy issues in processing of recycled plastics, the trade-off with using virgin plastics? In actual energy terms, there are virtually no energy issues in the processing of recycled plastics. I work with companies that are processing large elements of recycled plastics. One of the companies I was with about a month ago is making loads of non-visible parts and non-critical parts out of 100% recycled plastics. Their energy use in the processing is very similar to the energy use as it was when they used virgin plastics. The benefit is, of course, that they're using recycled plastics which have an embodied carbon of only 20% of that of the virgin plastics. So in that sense, using recycled plastics is not benefiting them in the energy they use in their factory, but it certainly is benefiting them in terms of their overall carbon footprint. So there's no real trade-off in that. Sorry, I think actually it's much the same, but the embodied carbon is much less. Okay, thank you. Can you really save 30% of the energy used in plastics processing? That seems a lot. It is, yes. So the answers to, to the question, can you really save 30%? Absolutely. Actually, in many companies, it's more than 30%. Uh, I know this is going to sound strange, but if once I've found the 30%, I'll continue counting till I get to 40%, but I rarely submit a report with over 40% savings because I think it demoralizes the site management. But the reality is, over the past 20 years that I've been doing energy surveys for plastics processors, the average is around 30%. Sometimes it can be as low as 18 to 20%, but 30% is the average. Yes, it seems a lot, and the main reason is most plastics processors, doesn't matter where you are in the world, have not focused on energy costs and reducing energy. It's a lot, and it's doable. Thank you. Wouldn't solar energy be more effective in Asia than in Europe? Yes, in many parts of Asia, somewhere like Thailand, Malaysia, Indonesia, would probably have a greater output of solar energy and almost certainly not show the same winter-summer change that we suffer in Europe because of the, a lot of Asia is closer to the equator. So it would be more effective, yes. Whereas in the UK or most of Europe, you're probably only going to get 16 to, or well, slightly less, or depending on how you run your factory, 16%. In Asia, it may well get up to 22, 24%. It again also depends upon how you run your factory, if you're running 24/7 or if you're running 24/5. Solar energy would be more effective in Asia than in Europe, but it's still going to mean that it's marginal in terms of running your factory on solar energy. Yes. Oh, sorry. Thank you. Are bio-based plastics really a solution to net zero? No, they're not the only solution. They're part of the solution. They may well turn out to be a minor part of the solution, but they're on the market. People are talking about them, and therefore I included them because if we're really going to get to a circular economy, if we're really going to reduce our dependency on fossil fuels, then we need to know what the alternatives are. Strange as it may seem, the fossil fuel-based plastics industry is actually a relatively recent thing. By that I mean that polyethylene, all of the main materials were developed and discovered pre-World War II, and almost all of the materials used plant-based plant-based materials before World War II. The actual growth of fossil fuel-based plastics only really happened at the end of World War II, and until, say, 1948, something like 100% of plastics were produced using bio-based sources. I don't think bio-based plastics are absolutely the solution at the moment. I think they can and show the potential to be a big contributor in the future. Are they really a solution? They're not the only solution. They may be part of the solution. Thank you. We do not heat our factory but use air conditioning for some areas. How does this affect net zero? Okay, I sort of alluded to that in the thing on heating, and by saying that heating is mainly in Western Europe, USA, that sort of stuff. If you're using air conditioning, you won't be actually burning a fossil fuel in the production of the air conditioning. It will be an electrified process, so you use a chiller or a split or something like that. So the use of air conditioning will appear in your scope 1 emissions, that's your scope 2 emissions, that's your use of energy from the grid. So that will appear in your electricity bill, and air conditioning will be there, but in essence, air conditioning will be small. For most of the factories I've been in Southeast Asia, the use of air conditioning will be relatively small in terms of, or compared to, the use of energy from running 10 or 20 injection molding machines. So air conditioning is already electrified, it's already there, and it's part of the carbon neutrality process if you want it. It's not part of the reducing gas use, which is in scope 1. Thank you. How do I see hydrogen energy use in plastics processing? It's a good question. I am not sure of how the hydrogen economy, and I put that in inverted commas, how the hydrogen energy economy is going to develop. There's a lot of work being done on hydrogen as a potential replacement for domestic gas heating in the UK. There's a lot of work being done on hydrogen as a potential for storage of energy which is generated by, say, wind or solar, which is not needed. By that I mean hydrogen becoming the storage mechanism. Hydrogen in plastics, almost the only area that hydrogen energy would have well, there are two areas where hydrogen energy would have a direct and quantifiable impact in plastics processing. One is on heating of the factories, which the plastics processor is not going to be able to do much about that because currently there's no hydrogen entering the gas stream. I've got a gas main outside my house, so hydrogen is not in that gas stream. The other is, could we think potentially about replacing the use of gas in rotomolding, that's LPG or something like that, in rotomolding with hydrogen? There's a couple of small problems there. One is burning hydrogen. It doesn't have the same calorific value as conventional LPG gas, so you've got to burn more of it to get a rotomold, or you would have to burn more of it to get a rotomold up to temperature. The other is that the hydrogen molecule is actually quite small. Compared to the molecules of natural gas, hydrogen molecule is quite small, and there's actually some concerns that leaks may occur in gas mains because of the presence of the hydrogen molecule being able to slip out these smaller holes. So I don't see really hydrogen becoming a major factor in either rotomolding in the near-term future or in heating our factories. I think that's a technology which is at the earliest 10 to 15 years away. Thank you.
That's all the questions we have, Dr. Robin. Thank you very much.
Not at all, Param.
Before we end this session, could you please give final remarks to the audience, please?
Right. Final remarks. Net zero has got a lot of publicity. A lot of companies are talking about net zero. What we've tried to do in the last hour or so is just go through the sort of actions you can take. Now, you may want to take them because you want to go down the net zero route, but frankly, a lot of the actions you should take because you want to be more profitable. Net zero is going to involve a change in how things happen. It's going to involve huge societal change. But below that, at the plastics processor level, reducing energy use, reducing waste, reducing materials use, reducing gas use are all sensible economic measures that you should be taking to reduce your costs. And I think we see net zero as this huge challenge which is going to cost us money. We're at the start of this net zero journey. It's 2023. We're looking at targets for 2035. I think we ought to be doing the good things now, which contribute to net zero, but also contribute to our bottom line. We see it as a challenge. Let's see it as an opportunity to make more money and to be good citizens at the same time. It's a challenge, but it can also be a huge opportunity. Thank you.
Thank you very much, Robin Kent. That's an excellent presentation discussion on the net zero 10 top tips for the plastics processing. Appreciate for a contribution for this program today for the Plastics News Server. Thank you very much.
Thank you.
Guys, that's the end of the session today on the net zero issues for the plastics processor. I'm hoping that you find this session useful, and I look forward to welcoming you in the next Plastics News Server episode. Thank you all for joining. Bye-bye for now.